So question 4, we are given three planes, each written in Cartesian form, and we've got to explain whether or not any of them are parallel. It's kind of the reverse of the previous vector question we did. Now we're looking at the Cartesian equation and coming up with the three normals, because if the planes are parallel, then the normals will be parallel, which is much quicker. So here we go. We look at the first one, 1, 1, 1. The next one, 1, -1, -1 from the coefficients here, which if you negate this, because obviously a normal one way, we can reverse it and it'll still be a normal to the plane. So this is the same as -1, 1, 1. And then the last one, no x and 1, 1. So 0, 1, 1. And of course you notice that the we've got 1, 1 as the kind of common last pair of coefficients. But anyway, clearly none of these are parallel because there's no way any of them is a multiple of the other. And so we can say that none of the planes are parallel. So I'm guessing one is for identifying the normals and one for saying none are parallel. Then when we move on to part B, we're asked to solve the system of equations. I put a copy of it down here so that we can get to work on it. Now, if we add the first two planes together, and this is a whopping 3 marks for what we're about to get, we get that 2x is equal to 11 because the y's and z's cancel out when we add. So we get 2x is 11, which means x must be 11 over 2, a unique solution. And then, though, if we add the second and third ones together, then this time we're left with x is equal to 8. So that's another unique solution, which is totally inconsistent with the value we just got from the first two. Therefore, we can stop straight away and say the system has no solution as the equations are inconsistent. And that would be our reasoning. So a quick 3 marks once you've realized, but obviously you're probably going to go back and check your working a little bit there because it's fairly unusual. The way it's written, solve, makes you think that there is a solution. Anyway, on the next page, we're asked to give the geometric interpretation of the solution. So there are no, so we know it's there are no solutions. But for this one, because the three planes are not parallel, so that means that none of them are can be coincident or anything like that. Plus the fact that the system has no solution, then the only possibility is that the planes will intersect in 3 parallel lines, kind of like this sketch here. And a sketch might help you explain it for your 2 marks there, to show that that's what's going on. I think I've got a link down below to a sort of sheet that summarizes all the possible systems of the solutions, the geometric. And also here comes a little video just to have a look at these on a site. Here's the 3D plotter made by CPM that you can find on the internet. I've put the 3 planes in here just to have a quick demo of what it actually looks like. I've got the x-axis here, y-axis vertical there, and the z-axis coming out here. And as I start rotating the planes around, you can maybe see what's going on here. There's somewhere around here, we're kind of looking through a gap between the planes here. So they're all intersecting in kind of parallel lines. But yeah, anyway, there's our system of planes.